Welcome to this video on how to add and subtract vectors. Shown to the right are two vectors u and v. The vector u has component form 4, 2, and the vector v has component form 1, 5. The initial point of the vector u is the point 0, 0, and the terminal point of the vector u is the point 4, 2. The initial point of the vector v is the point 0, 0, and the terminal point of the vector v is the point 1, 5. We can add these vectors by placing the initial point of one vector at the terminal point of the other. We can place the initial point of the vector v at the terminal point of the vector u. This gives us the resultant vector u plus v, which is now shown to the right. We can calculate the component form of the vector u plus v from the components of the vector u and the components of the vector v. The vector u has component form u1, u2, which in this example is equal to 4, 2. The vector v has component form v1, v2, which in this example is equal to 1, 5. I'll explain this further now. u1 is the horizontal component of the vector u, which is equal to 4, and u2 is the vertical component of the vector u, which is equal to 2. v1 is the horizontal component of the vector v, which is equal to 1, and v2 is the vertical component of the vector v, which is equal to 5. We can see to the right that if we add u1, the horizontal component of the vector u, to v1, the horizontal component of the vector v, that will give us the horizontal component of the resultant vector u plus v. And we can see to the right that if we add u2, the vertical component of the vector u, to v2, the vertical component of the vector v, that will give us the vertical component of the resultant vector u plus v. We add the vectors u and v by adding the components of the vector u to the components of the vector v. u plus v is equal to u1, u2 plus v1, v2, which is calculated as u1 plus v1, u2 plus v2. u1 is equal to 4, and v1 is equal to 1. u2 is equal to 2, and v2 is equal to 5. 4 plus 1 is equal to 5, and 2 plus 5 is equal to 7. So we've calculated that the component form of the resultant vector u plus v is 5, 7, and we've calculated this from the components of the vector u and the components of the vector v. The vector u and the vector v can also be written as a linear combination of the vectors I and j. I and j are standard unit vectors. The standard unit vector I is a horizontal vector with length equal to 1, and the standard unit vector j is a vertical vector with length equal to 1. We can write the vectors u and v, now shown to the right, in terms of I and j. We can write the vector u as being equal to 4i plus 2j. and we can write the vector v as being equal to I plus 5j. We can add the vectors u and v by adding the horizontal or I components of u and v, and by adding the vertical or j components of u and v. When we add 4i plus I, we get 5i. And when we add 2j plus 5j, we get 7j. So we've calculated that the vector u plus v is equal to 5i plus 7j. This vector is now shown to the right. I'm now going to demonstrate and explain vector subtraction. Shown to the right are two vectors, u and v. When we write the vector u minus the vector v, we mean the vector u plus the vector minus v. The vector minus v has the same length as v, but it points in the opposite direction to that of v. We can add the vectors u and minus v by placing the initial point of minus v at the terminal point of u. This gives us the resultant vector u minus v. We can calculate the component form of u minus v from the components of the vector u and the components of the vector v. The vector u has component form u1, u2, which in this example is equal to 6, 2. The vector v has component form v1, v2, which in this example is equal to 3, 5. The vector minus v is equal to the scalar minus 1 multiplied by the vector v. The component form of the vector minus v is equal to minus 1 times v1 minus 1 times v2. v1 is equal to 3 and v2 is equal to 5. Minus 1 times 3 is equal to minus 3, and minus 1 times 5 is equal to minus 5. So we've calculated that the component form of the vector minus v is equal to minus 3 minus 5. This vector in standard position extends from the origin to the points minus 3 minus 5. We can calculate the component form of the resultant vector u minus v by adding the components of the vector u to the components of the vector minus v. Adding the horizontal components of u and minus v, we have 6 plus minus 3, and adding the vertical components of u and minus v, we have 2 plus minus 5. 6 plus minus 3 is equal to 3, and 2 plus minus 5 is equal to minus 3. So we've calculated that the component form of the resultant vector u minus v is 3 minus 3, and we've calculated this from the components of the vector u and the components of the vector minus v. This vector is now shown to the right. We can also express the vectors u and v, shown to the right, as linear combinations of I and j. The vector u is equal to 6i plus 2j. And the vector v is equal to 3i plus 5j. The vector minus v is equal to the scalar minus 1 multiplied by the vector v. This is equal to minus 1 times 3i plus minus 1 times 5j. Minus 1 times 3i is equal to minus 3i, and minus 1 times 5j is equal to minus 5j. So we've calculated that the vector minus v is equal to minus 3i minus 5j. This vector is now shown to the right. The vector u minus v is equal to the vector u plus the vector minus v. This can be calculated by adding the horizontal, or I components, of u and minus v, and by adding the vertical, or j components, of u and minus v. 6i plus minus 3i is equal to 3i. And 2j plus minus 5j is equal to minus 3j. So we've calculated that the resultant vector u minus v is equal to 3i minus 3j. This vector is now shown to the right. To summarize, in this video, we've learned how to add and subtract vectors. We've learned how to do this geometrically. We've also learned how to calculate the components of the resultant vector. If you found this content useful, please subscribe to the channel to receive more content. Thank you very much for watching this video. See you next video.